Hello everyone. Our topic for the final year project is the food recommendation system. Group members are Ayush Singh, Har Soni, and myself Ocean Thakre. Our project mentor is Professor Vijay Kamble. Since the arrival of online food ordering apps in the market, the food delivery through the online platform has increased exponentially. Online food recommendation systems have ended up being helpful in diverse circumstances by engaging the customer to conquer the information overburden issue, helping with the decision making cycle. With this online ordering system, the customers are exposed to a realm of new choices. Our system analyzes all the past order of a customer, and based on the various factors such as the cuisine of the dish, the main ingredients and other such factors, the system would recommend the customer new similar dishes. As we all know, while ordering the food, we waste a lot of time deciding which food should we order, and also we can't decide from which restaurant we should order the food. So, with the help of our system, customers can order their favorite food without wasting any time, and it will also give the best restaurant for each recommended dish. Also, while ordering the food, some users are concerned about their health. Using this system, user will get the recommendation of healthy food only. For this system, we have used three methods that are term frequency, inverse document frequency, and cosine similarity. Term frequency shows how frequent the term occurs in the document, but there is a problem. TF gives more importance to word occurring frequently while ignoring the importance of rare terms. This problem is resolved by IDF. It is defined as the number of document where the term T is present. Then we have a TF-IDF weight, which is a statistical measure used to evaluate how important a word is to a document in a collection. At last, we have a cosine similarity. It shows how closely the two sentences are based on what angles their respective vectors make. Let me explain to you with an example. Suppose the user has already tried these three dishes. From that, we will create the index of the words and then form a vector. If the ingredient is present, then the index will set to 1, and if not, then it will set to 0. Then we will find the idea using the formula and will form the vector. After that, we will calculate the TF idea weight and will perform these same methods on other dish. And with the help of cosine similarity, we will get a similar dish.
Coming to the demonstration of our project, let's first take a quick look at how our dataset looks like. This is the dataset before processing, which contained different columns of ingredient, tags, types, cuisine, etc. After processing, we bunched all these columns together into a single column named keywords, which will be quite useful in forming vectors. Then, looking at the restaurant dataset, this is a dataset taken from Zomato website, which consists of restaurant name, location, cuisine, rating, etc. After that, we divided dataset into different types so that we can avoid overlap between types while recommending a dish. Further going, we create TF-IDF vector using TF-IDF vectorizer function from a scalar library. And after that, we create cosine similarity matrix for each and every type. Let's take a look at the cosine similarity matrix. So, as you can see here, the values are ranging from 0 to 1, where 0 means the recipes are not related and 1 means they are highly related. After that, we create a recommending dish function, which takes input as the name of the recipe that the user had previously ordered. We then segregate the recipe based on different types, and after that find the cosine similarity matrix where it belongs and take out the row, and then finally sort it descendingly to find the top 5 values. Looking at the restaurant recommending function, we take in as the cuisine of the recommended dish and the location of the user as the two inputs, and by segregating the data set based on these two inputs, we finally get the restaurants which are valid. After that, we sort them as descendingly based on their rating to find the top 3 restaurants. Here, as you can see, we have done user profiling, wherein different users have different recipes that they have ordered in the past, and also the location of the user is mentioned. So based on these two information, our recommending function will find out the corresponding dishes and their restaurants. So let's take a look at our results. So as you can see, this is the recipe that the user had previously ordered and the user belonged to this area. So correspondingly, these are the recipes that the user will be get recommended. And also these are the restaurants that are present in his area which can provide this dish, and they are also the top rated restaurants in that area. As you can look, for each and every recipe there are 5 subsequent recipes that are recommended. These recipes are quite close to the original recipe but not the same, so that the user gets different recipes every time he orders. The restaurant recommendations are quite good because they are depending on the rating. This is done for each and every recipe, as you can see. Like that, the user gets to have new recipes every time, and also it is very easy to find those recipes because of our restaurant recommendations.
Now coming to the application part, 81% of the Indian population orders online food through these food delivery apps, for example, Zomato, Swiggy, Food Panda, Box8. And like this, there are many other food delivering apps. So when our system will be combined with this app, this will give us a very huge market with a lot of potential in it. And our system will also increase the user experience. Now coming to the conclusion part. So this system can predict 5 dishes which the user might like, and for those predicted dishes, 3 corresponding restaurants, the best 3 rated restaurants, will also be predicted from the same area. And our system uses content-based recommendation system and concepts like term frequency and inverse document frequency. And at last, the recommendation in our system is more of a food oriented recommendation, unlike the existing apps like Zomato, which are more focused on the restaurants oriented recommendation. That is, they will recommend some restaurants which you might like, and then for that particular restaurant, some dishes from their menu will be predicted. But our system will give you dishes that you might like, and then it will recommend you the best restaurants where you can find those dishes. So that's it from our side. Thank you.